So last time on Monday, I sort of reintroduced the aggregate demand, aggregate supply model, and I used Cowan and Tabarrok's presentation of the model, which is a dynamic one, just to say that they use inflation and real GDP growth on the axes, such that their long-run aggregate supply curve is actually 3%, or whatever the real GDP per capita growth rate is for the country. Their aggregate demand curve is a measure of spending change, or spending growth. So that is the change in money plus the change in velocity. Okay, and then their short-run aggregate supply curve is related to expectations about inflation. And I encourage you all to go back and watch the Cowan and Tabarrok videos related to the basic aggregate supply, aggregate demand model. Well, today what we're going to do is we're going to look at the alternative development of the aggregate demand curve. Where does the aggregate demand curve derive from? Can we find something underneath it? This is analogous to the way that in intermediate microeconomics, you say, okay, what is a demand curve? And the demand curve is essentially related to changes in prices and how those affect the quantity demanded of a particular good. You guys remember this maximization strategy from intermediate micro, using indifference curves and budget constraints, and so on. So if you have good X and good Y, and the price of good X falls, right, then we see an increase in the quantity of good X purchased, deriving the demand curve. Well, here, what we want to do is we want to derive the aggregate demand curve, and that's where the analogy stops, because we're not doing anything related to indifference curves here. Instead, we're thinking about aggregates, and we want to think about what affects the demand for goods and services, the purchases of goods and services. How are, in particular, consumers, government, and investors, how do they make their decisions about how much to buy? And so we're looking at expenditures by entities within the economy and how expenditures come out of the economy or build into aggregate levels. Way back when, we built a model of consumption related to income, and we assumed that consumption started at some non-zero level, and that it increased at a slope somewhat less than 1-for-1, such that there was a marginal propensity to consume that was somewhat less than an increase in income. The idea being that if you got another dollar, would you spend that whole extra dollar? I would, probably, but the idea here being that no, you might spend 80 cents of it and save 20 cents of it. The difference is what would be saved. I have some issues with this. I said so then, and I'll say so again now. In the aggregate, the idea that consumption can never be zero puzzles me. Where does it come from? Where does the consumption that we're doing here come from if it does not come from something that's been produced? How can you consume something that doesn't exist? And output here, has to be equal to at least the consumption level. Now, I'm able to overcome my difficulties with this when I reflect upon it and say, you know what? All this over here doesn't really matter. And this is similar to the way that we think about supply and demand. Think about the market for shoes, and think about the supply curve and the demand curve for shoes. There are people who will pay $1,000 for a pair of shoes. They exist, especially if they're like first edition Jordans, never been worn, right? They'll pay way more than that for them, okay? And they're way up here. But for the most part, we don't have a lot of data about those shoes. Very, very rare. Very thin market, and one would say probably a completely separate market from the regular market for regular shoes. Instead, in the market for shoes, what we have are a bunch of transactions that occur here-ish, around this area somewhat. And our idea about supply and demand would be estimations, statistical estimations of a supply curve and a demand curve in this region that have statistical variance involved as well. We don't actually know where supply and demand intersect, do we? We have an idea, we have a picture about the region, but we don't know for sure. Similarly, in the United States or advanced economies that have sophisticated financial structures, such that we would actually be interested in thinking about aggregate outcomes and changes, for the most part, we don't observe a whole lot of zero consumption happening. Most of the action in a real world economy is going to be in this region. And so the fact that this doesn't work, I'm able to let it go, finally. Something that I have struggled with in ways that non-economists don't struggle with. It's an intellectual problem that I'm like, does it make sense? And to me, no, but it doesn't matter because we're only really interested in what's happening up here. Now, if there is such a thing as a marginal propensity to consume that is in some way less than 1, we're going to get something like a consumption not exactly the same as income, such that we can find an equilibrium at the margin. Now, the way our textbook walks through this is it on the axes here, we have income and then we have planned expenditures. Planned expenditures. What's going on here is the idea that if we spend everything that we earn, we would be on this line. But we know that we don't. We do save some. And so there is this other line that incorporates the marginal propensity to consume within it. And this becomes important because of how this line moves. So this line includes within it all of this stuff. And these are our planned expenditures. These are our actual expenditures. One of the things that affects our planned expenditures is consumption. Now, consumption, we have stated before, is a function of total income and taxes. Now, why am I throwing taxes into this? Because that is going to be one of the policy levers that we're going to want to manipulate coming up. So I got to build it in now so that I can manipulate it later. It's important to recognize that I'm not saying C multiplied by parentheses y minus t, but instead I'm using this as a functional notation. So C is a function of y minus t. I don't know exactly what that function looks like. In times past, we've called it C0 plus some other thing that incorporates the marginal propensity to consume. Questions? Okay. For the time being then, I'm going to think mostly about how this curve changes when y changes. In order to do that, I'm going to say that potential expenditure, or planned expenditure rather, is equal to the function of consumption related to output minus taxes plus investment plus government spending. But for the time being, I'm going to hold taxes constant, I'm going to hold investment constant, and I'm going to hold government spending constant. So I put little lines over the top of them to say we're not going to let those vary. Those are going to hold still. Okay, so what happens? If income increases, that is one of the parts of this model. And so y goes up, consumption goes up. Consumption goes up by an amount that is not as great as y. So let's move consumption up a little bit. By moving consumption up a little bit, here's what happens. Y changes by this amount. Over here, is y going to change by more or less than y changes over here? No, it would seem so, but it's exactly by the same amount. Why? Because we've moved from one point on the 45-degree line to another point on the 45-degree line. So a small change this should be a change in y that has led to a change in consumption, right? A small change in y leads to a large change in y. How can that even make sense? How can that even make sense? The idea is that given less than one marginal propensity to consume, when there's a little bit more spending happening, it propels extra spending. We'll come back to that because I think I'm saying it slightly wrong right now. Okay, where is the interest rate in all of this? It's not there yet. R is absent from this model thus far. And if you'll remember, going back to earlier chapters about consumption, we left R out then too, at least at the beginning. In other words, what we're thinking here is that since we're trying to build a model of what happens in the short run, interest rates aren't going to play a major role. Okay. Maybe I'll come back to some of this stuff. Okay. Let's do this now. Let's say what happens if the government, instead of being held constant, exogenously changes the amount of money that the government is spending, or increases government expenditures. An exogenous increase in government expenditures would work the same way. There's an increase, a change in the amount of government spending, and we measure that by the vertical distance here. But because we're moving along a slope here, this vertical distance in terms of changing government spending leads to a larger than that change in total expenditures and a larger than that change in total output. How much? Well, what we're asking is, what is the change in total output that is consequent of a particular change in government expenditures. The way to think about this is the government spends some money. Let's say the government spends $1 million and it hires a contractor to do some work and it pays the contractor $1 million. That contractor takes that $1 million and does what with it? Well, they apply the marginal propensity to consume to it. So suppose the marginal propensity to consume is 60%. People consume 60% of their income and they save the other 40%. Well then, that government contractor spends 60% of what they earned, and who do they spend that money with? Well, doesn't matter. Anywhere, somewhere in the economy. And whoever gets that money out there in the economy, they receive that money, and they take 60% of what they receive and respend it, and they save 40% of what they received. So then, how much gets spent in total? Well, the government spends the total amount, but then whoever receives that money spends whatever their marginal propensity to consume is of that money. And then whoever gets that money spends whatever their marginal propensity to consume of it is, and that would be the marginal propensity to consume squared. And we move on and on and on, all the way through all the people in the economy until the last number, the marginal propensity to consume of the last person, right, ends up with a very, very, very small amount of increased spending. Our textbook explains this by giving the example mathematically of saying, okay, if you've got z is equal to 1 plus x squared plus x cubed plus ... for an x that is greater than 0 but less than 1, what does that equal? This infinite series. And they use a trick. They say x times z equals x plus x squared plus x cubed plus x to the fourth plus ... Well, then we can take this term and subtract this term from it. We can take this equation and subtract this equation from it, and we're left with z minus xz is equal to this minus this. Well, if I take this minus this, then this x and this x are going to cancel. X squared and x squared are going to cancel. X cubed and x cubed are going to cancel. And I'm going to be left with just 1 plus whatever the last x was going to be on this end. X to the large number. But remember, x to the large number is really, really, really small. So we can toss that out and neglect it and ignore it. And then we get this all by itself. We can factor out the z, and we're left with 1 minus x equals 1. So then z is equal to 1 over 1 minus x. All of which I'm doing in order to show that when the government spends another dollar, how does it affect total output? The output is, the change is equal to 1 over 1 minus whatever the marginal propensity to consume is. So here's your z, that's dy dg, and here's your x, marginal propensity to consume. So what if the marginal propensity to consume is 60%? If the government spends $1 million, how does that affect the overall economy? How much is the change in y? Well, 1 over 1 minus 0.6 is equal to what? 1 over 0.4. What's 1 divided by 0.4? Is it 2.5? So then $1 million of government spending results in an increase of total output or total expenditure of $2.5 million. And so we've got a multiplier effect going on here. Do you believe it? I'm not so sure. There's an element of truth to it. And it's built into the model here. Okay. We could walk through the same scenario, thinking about instead of changing the amount of government spending, let's instead change the amount of taxes. If we, instead of changing the amount of government spending, change taxes, how does that work itself out? Again, our planned expenditure is equal to C of y minus t plus I plus g. If we decrease taxes, that would lead to this term getting larger. So that would be similar to, again, a shift up of our planned expenditures. How much? Overall consumption increases by, since it's a function of this, consumption will go up by how much? By, well, whatever the change in taxes was, that's the extra money that the consumer has in their pockets. So we'll multiply that by their marginal propensity to consume, and that's how much planned expenditure will go up. Or if we want to walk through it, we could say, what is the change in y given a particular change in t? And we will, if we work it through, we find that it is equal to negative marginal propensity to consume divided by 1 minus the marginal propensity to consume. Why? What is this telling us? If taxes go down by $1 million, there's $1 million less that people have to pay in taxes. How is that going to affect total expenditures? Well, we would take negative, if we're going to keep 0.6 as our marginal propensity to consume, negative 0.6. Make sure I'm doing this right. It's important to know that the change in taxes is a negative change in taxes. Minus over 1 minus 0.6. So that's negative 0.6 over 0.4. What's 0.6 divided by 0.4? It's negative 2.5, isn't it? Or 3/2.
3/2.
Which is 1.5. Right?
Yes.
No, I feel like he goes wrong here. 0.6. Okay. Okay. So again, there is a multiplier effect that occurs here as a result of a change in taxes. Okay. So then, we're sort of working through this model, discussing how to build our IS curve. Okay. And we've said so far that investment is being held constant. But if we remind ourselves back of what we've studied in earlier chapters, we remember that for some reason interest rate is going to be the thing that brings about equilibrium in these markets. So then instead of holding interest constant or investment constant, we're actually going to rewrite and say I is not just constant, but investment is actually a function of the interest rate. Again, this is not investment times the interest rate. This is investment is a function of the interest rate. How do we want to think about that? How do interest rates work their way through the broader economy? If we think about, actually Let's build this graph down here. We think about interest rates and how those influence the amount of investment that happens in the economy. The interest rate is the time price of money. So if the interest rate goes down, that means that investors are going to find it worthwhile to take on projects that would otherwise have only a low rate of return, so low that it's not worth investing in. As the interest rate falls, more and more projects seem worthwhile to investors. So as R goes down, I of R goes up. Well, if total investment in the economy increases as a result of a fall of the interest rate, how does that influence total output? So I'm changing the labels on the axes here. If the interest rate falls, and here I'm using the same interest rate, how does that affect total output? Well, if there's more investment in more projects, then that's going to increase total output. So then a change in R down leads to the change in investment that is positive, that also leads to a change in output that is positive. This change in output can be then translated back over to this model. And for a given change in output, well, that should be more of a 45-degree line. Okay. That fall in interest rates, so R1, output 1, R2, investment level 2, output level 2. Right, as the interest rate falls, it shifts up our level of consumption. How? Because inside of this function, our planned expenditure function is equal to C as a function of T, of Y minus T, plus I as a function of R plus G. So then as R goes down, planned expenditures goes up. This line, this graph, where we have the interest rate and output on the axes, this is our market for goods and services. That gets brought into equilibrium through adjustments of the interest rate. And so we have here the relationship between investment and spending. So we call this sucker our IS curve. That's our IS curve. And we're going to build on top of this, because every decent market needs to have both a demand curve and a supply curve. We're going to build on top of that an LM curve. So what I'm trying to demonstrate here is how the multiplier effect, which is the main point of this angled graph here, which actually gets called, by the way, the Keynesian cross. Keynes didn't actually invent it. It was developed by John Hicks as a way of explaining Keynes's general theory. Keynes didn't necessarily completely agree with Hicks's interpretation. Neither did anybody else, but this is sort of what took hold. So in this market, we're going to try to find equilibrium in the goods and services market as moderated by changes in the interest rate. Now, before we get too much into that LM curve, which has to do with liquidity preferences, we want to think through some policy implications here. For example, if the interest rate is held constant and doesn't adjust, and there is a change in government spending such that our planned expenditure curve shifts. So the interest rate is being held constant, but the government spending is changing. How does that relate to my IS curve? Well, I've said that interest can't change. So then it's going to have to be on some particular interest rate, not allowing for the interest rate to adjust. If there's a change in government spending, then how will that show up on this graph? It will show up as, because we have to move from Y1 to Y2, it'll show up as a shift of the IS curve. The point being that government is an exogenous variable to this model. Therefore, exogenous variables cause the whole curve to shift. Endogenous variables, we can move along the curve, but exogenous models cause the curve to shift. This is true both for government spending and for taxes. Government spending, changes in government spending and changes in taxes, both of these are part of what is best understood as fiscal policy. And fiscal policy is one approach for the government to try to address fluctuations about the business cycle. So the government gets involved through Congress in passing of laws to change fiscal policy, the amount of money that the government is going to spend or the amount of taxes that the government is going to charge. And changes in fiscal policy will have the consequence of shifting the IS curve. Why? Because Congress doesn't have anything to do with the interest rate. Who influences the interest rate? The Fed. So we're separating out how fiscal policy influences equilibrium in the goods and services market from how monetary policy, activities by the Fed, affect it. Okay, so fiscal policy is related to our IS curve. What about the LM curve, the second half of this thing? How can we think about that? The LM curve is about liquidity. The liquidity preference for money. one assumption we need to bring here is that in the short run, the interest rate is not really the same thing as the long run interest rate. The long run interest rate is determined how? The natural interest rate. How is that determined? By subjective preferences for time. Do I want the gumball now or the ice cream later? That is the true root of interest rates. However, in the short run, interest rates behave a little bit differently from the way they do in the long run. In the short run, the interest rate adjusts to satisfy the demand by the public for liquid money, for cash. So then we're going to use some variables that are similar to what we've used in the past. We're going to say that M is equal to the supply of money. And that is something that the Federal Reserve Board controls. Then we're going to say that P is equal to the price level and if you remember from the last chapter of Mankiw, in the short run, what does he say about prices? They're sticky, right? In the short run, prices are sticky. Okay. So then M divided by P is a description of real money balances. In other words, the existing claims to buy stuff in the real world. What is money really? It is a claim to buying something. It is an asset that other people might want, might have a demand for, and they're only going to accept it if you offer them enough of it to get the thing that you want. So then, as the price level changes, if all of the prices of things in the economy change, then a certain amount of money is only going to have one particular effective purchasing power in terms of real money balances. Real meaning the ability to buy real things, real stuff in the real world. So then, because the Fed is involved and price level is somewhat fixed, we're going to say that the M over P supply is, in the short run, is fixed. What does this mean? Well, one thing that it means is that as far as the supply of money, it doesn't have anything to do with the interest rate. It isn't caused by the interest rate. In other words, quantity theory of money says that in the long run, right, changing the supply of money doesn't change the amount of actual stuff you can buy. So if I were to start building a model here, I would say, well, if interest rate is my y-axis, but there is no interest rate at all involved in the supply of money, then relative to the interest rate, the supply curve is perfectly inelastic. It isn't affected by it at all. In other words, so in terms of effective liquidity preference for money, the supply is fixed. Okay, well, what does determine the interest rate then? The only other thing that's available that could affect it, the demand for money. How much money do you want to have in your checking account or on Venmo relative to in your savings account. That's probably the first time that I've ever used Venmo as an example. I've been trying to set my Venmo up and I can't figure it out. I'm too old. What is your opportunity cost of having money in Venmo? You're going to put $40,000 into Venmo? Probably not, right? You're probably going to take $38,000 of that and at least put it into a savings account. Why? Because you can earn interest by keeping it in savings, whereas in Venmo, it's not really going to earn you interest. Which is to say that as the interest rate goes up, you would prefer to hold less of your money in the form of cash or real money balances. So then the higher the interest rate, the less of your money you're going to hold in cash. The lower the interest rate, the more of your money you're going to hold in cash. Why? Because the opportunity cost of holding cash is lower. You're not going to earn interest anywhere else. So you might as well just keep it in cash. So then this is our demand curve. And so then what do we get out of this? We get out, our demand curve is a function of the interest rate, whereas the supply curve is not a function of the interest rate. Where the two come to equilibrium, we find the market interest rate. What could change? Well, the Fed could increase or decrease the quantity supplied of money. If the Fed dramatically reduces the quantity supplied of money, then my supply curve shifts left. As a result, what happens? The interest rate goes up. So an increase in M leads to an increase in R. This doesn't quite seem to make sense. If there's less money in the economy, then that's deflation. And it would seem to be that with deflation, people would want to hold more money in terms of cash. Well, the assumption that is brought into this model is that with a decrease in the quantity supplied of money, it doesn't immediately affect the price level. Instead, all that it's affecting is the interest rate. So to translate this, we take our money preferences model, and we say, okay, what happens? What happens? We want to also include in here income, because we want to translate this all over to another graph where this is what we have on our x-axis. This graph is the same as the graph for the IS curve. So we're going to go from here, and instead of creating the IS curve, we're going to create the LM curve. And the idea here is that if there is an exogenous change in y, if y increases, that will lead to an exogenous shift of this curve to a higher interest rate. And if I take this over to the market for goods and services, since y increased, y went from one number to a bigger number, y increased, as y increased, R also increased. So now I've got an upward sloping LM curve in terms of liquidity preference. And this describes our LM curve. And again, we're going to throw onto this curve again later on, our IS curve, and together they describe our aggregate demand, our overall level of aggregate demand, which is mostly captured in Y. Aggregate demand is captured in Y, and that is, in this case, brought into equilibrium by the freely fluctuating changes in the interest rate. So again, our equation Y equals the function of consumption related to output and taxes plus the rate of investment as a function of the interest rate. This is our IS curve, and then this equation describes our LM curve, and together, when brought into equilibrium, we're going to bring these into describing real GDP growth and inflation. They're going to help determine our aggregate demand curve.